Vicky, what are you doing?
Oh, hi, Liberty. I'm watching TikTok. I feel amazed with this app. It is very entertaining, and you should try it. It has a lot of videos made by different content creators. But I wonder how this app was invented. I mean, whose genius are behind this amazing app? Do you have an idea?
You mean the computer programmers? Yes, they are the ones who are behind these amazing applications. You wanna know why? Come, let us watch this video.
Welcome to the world of programming. Today I'll be presenting my topic regarding in this field. As a programmer, I guide you on how to write codes and its different types for computer programs and mobile applications. Coding scheme is a standard code which tells the computer which data is represented by whom set of bytes. A computer uses a coding scheme to symbolize or represent data such as alphabets, digits from 0 to 9, and symbols in a standard code. There are three types of coding scheme, and the first one is the ASCII, that stands for the American Code Information Interchange. ASCII code was published in 1968 by ANSI, which stands for the American National Standard Institute. ASCII's code scheme is most widely used by personal computers. It is a 7-bit code and it represents 128 symbols and characters. The second coding scheme is the Extended Binary Code Decimal Interchange Code, or we can call as the EBCDIC. It is an 8-bit binary code for numbers and alphanumeric characters. It was developed and used by IBM, or we can call as the International Business Machines. It is a coding representation in which symbols, letters, and numbers are presented in a binary language. EBCDIC is widely used in IBM mid-range and mainframe computers. This encoding was developed in 1963 and 1964. This code is used in text files of S/390 servers and OS/390 operating systems of IBM. EBCDIC allows 28 or equals to 256 combination of bits. The 256 unique symbols represents decimal numbers from 0 to 8, lowercase and uppercase letters from A to Z, special characters, and control characters. The third coding scheme is Unicode. Unicode is a modern standard for text representation that defines each letters and symbols commonly used in today's digital and print media. Unicode uses 16-bit codes. It can represent 65,536 characters. Unicode was developed to replace ASCII code. Unicode represents the characters of all languages in the world. That's all. Thank you.
Did you know that engineers and programmers sat down and decided how they were going to represent a new type of information in binary form? That is why binary numbers are important, because it simplifies the design of computers and related technologies, which is very useful for every computer programmer. Also, the binary system is a system of numbering that uses only two digits, 0 and 1, to represent numbers, instead of using the digits 1 through 9 plus 0 to represent numbers. To translate between binary and digital in every binary number, the first digit is starting from the right side can equal 0 or 1. But if the second digit is 1, then it represents the number 2. If it is 0, then it is just 0. The third digit can equal 4 or 0. The fourth digit can equal 8 or 0, and so on. So computers rely on binary numbers and binary math because it greatly simplifies their tasks, and it is also a reliable way in storing data. For example, a computer's main memory is made of transistors that switch between high or low voltage levels such as 5 volts and 0 volts. Voltages sometimes low, but since there are only two options, a value of 1 volt would still be read as low. That reading is done by a computer's processor, which uses the transistor states to control other computer devices according to software instructions.
Octal numbers are widely used in computer application sector and digital numbering system. So octal refers to the base 8 numbering system. It comes from the Latin word for 8. The octal numbering system uses the numerals 0, 1, 2, 3, 4, 5, 6, and 7. So octal is another way to count numbers while humans normally count in tens and machines count in 2. It is possible to use any numbers as the basis for counting and calculation. So using octal is a convenient way to abbreviate binary numbers. Starting from the right, group all binary numbers into sets of 3 digits. Then add 0. Each 3-digit binary group translates into a 1-digit octal number. So let's start with binary number 0, 1, 0, 1, 1, 1, 0, 1. So group the binary number into 3. Add 0 to the left if necessary. So 0, 0, 1, 0, 1, 1 is 1, 0, 1. So convert each 3-digit group into an octal number. So 1, 3, 5. So combine numerals to form the octal numbers, which is 1, 3, and 5. So various symbols have been used in programming languages to designate octal, including the 0 or the letter O or Q. The digital letter combination 0 or O or the symbol and or base 8 can also be shown using the number 8 as a subscript.
The decimal numerical system is the most commonly used and the standard system in daily life. It uses the numbers 10 as the base radix. Therefore, it has 10 symbols, the numbers from 0 to 9. For instance, take the number 2345.67 in a decimal system. The digit 5 is in the position of ones, 100, which is equals 1. 4 is in the positions of tens, 10 to the power of 1. 3 is in the positions of hundreds, 10 to the power of 2. 2 is in the positions of thousands, 10 to the power of 3. Meanwhile, the digit 6 after the decimal point is in the tens, 1 over 10, which is 10 to the power of negative 1. And 7 is in the hundreds, 1 over 100, which is 10 to the power of negative 2 positions. Thus, the number 2345.67 can also be represented as follows.
Hexadecimal is a number system with base 16. It is represented by only 16 digits or value. These are So the hexadecimal numbering system is often used by programmers to simplify the binary numbering system. Computer use binary numbering while humans are use hexadecimal numbering system to shorten the binary and make it easier to understand. Are used in the following: to define the location in memory. Hexadecimal can characterize every byte of 2 hexadecimal digits, only compared to 8 digits when using binary. Second, to define colors on web pages. Third, to represent media access control or MAC addresses. Last, to display error message. Hexadecimal are used to define the memory location of the error. This is useful for the programmers.
Binary operation is an operation that requires 2 inputs. These inputs are known as operands. The binary operation of addition, multiplication, subtraction, and division takes place on 2 operands. Even we add any 3 binary numbers, we first add 2 numbers and then the third number will be added to the result of the 2 numbers. Thus, the mathematical operations which are done with the 2 numbers are known as binary operations. That is why most computer programmers use binary operations to make their task easier. Binary addition, the result obtained after adding 2 binary numbers to the binary number itself. In addition, example, 0 plus 0 equals 0, 1 plus 0 equals 1, 1 plus 1 equals 1, 0. So we have the carry 1, 1 plus 1 equals 1, 0. So we have also the carry 1, 1 plus 1 equals 1, 0. So let's carry the 1, 1 plus 1 equals 1, 0. So the answer is 1, 0, 0, 0, 0, 1, 0, and let's put the subscript to binary subtraction. The result obtained after subtracting 2 binary numbers is the binary number itself. In subtraction example, let's minus 1 minus 1 equals 0, 1 minus 0 equals 1. So 0 minus 1 cannot be, so let's borrow. 1, 0 minus 1 equals 1. So 0 minus 0 equals 0. So 1 minus 1 equals 0. So 0 minus 1 cannot be, so let's borrow the 1. 1, 0 minus 1 equals 1. So the 1 will be 0, so let's not bring down the 0. So the answer is 1, 0, 0, 1, 1, 0. And let's put the subscript 2. The binary multiplication are calculated similarly, so the other arithmetic numbers are calculated. Multiplication example, 1, 0, 0, 1, 1, 0, 1 times 1, 0. The answer is 1, 0, 0, 1, 1, 0, 1, 0. And let's put the subscript 2. In binary division, the method of binary division is similar to the one zero decimal system other than the base 2 system.
So in here, we have 3 divisor, which is 100, and dividend we have 3, which is 101. In here, the dividend is bigger than the divisor, so the answer is 101 subscript 2.